students, our new topic is power. Okay, so power is something like we have heard about it a lot of time, but we don't know actual power of power word. Okay, I can say that. So students, here some students get confused with the term energy and power. They think that energy is equals to power always. Okay, yeah, that you can pretend, yes, that is obviously somehow true, but not exactly. Okay, power is not just energy. Yeah, it depends on energy, but it is not exactly the exact value of energy. Okay, even the SI unit for power is different. So what is power then? Power is a rate of doing work. Okay, as you know students, that work is equals to energy. Okay, so that is why I have written here that how much power you are having, show your power. Okay, so that doesn't mean that I am trying to see your energy here. Like even teachers ask the students to learn the test and give the answers correctly. So some students are capable enough to score full after full marks, but some students are also like this, that even can't afford 1 marks to gain. Okay, so here the power of these two situations could be shown. That doesn't depend that they are not having any kind of energy there. Yeah, they are having different energy, but they are using it in different manner. Okay, so what is power then? Doing work with the rate. Rate here gives you the induction of time taken. So we can say that power is equals to work done in a particular time. How much work is done by somebody in a particular time, that is work. Let's suppose I'm giving you one example. Here I am having two students, and these two students are running. Okay, and I have let them race together, and in a race, so one student get win, and because he has reached here in a minimum time. Okay, and now this student is here only when he has just crossed the line, the boundary line, and here this student is just reached there. So we can say that the time taken by this student is more. So what is the situation here? Let's suppose these two are of equal age. So we can say that energy in both the condition are equal. Here both are having same kind of energy, but still one is a winner and the another one is not a winner. How come? Because of the time taken to doing some work. You know that energy is equals to work. That means this student can also do the same amount of work that this is doing, and this can do the same amount of work that this can doing, because these two are having same amount of energy. But the rate of doing work, that means in how much time they are doing this work, the time taken is a necessity part here. One student is taking a very minimal time to complete the task, and this one is taking a lot of time to complete that task. So here is the difference in these two. Now we can say that this student is having more power compared to this one. So this exactly done in terms of power. This is what physics says, that for a completion of the task, for a completion of a work, if two bodies are going together, so the minimum time that has been taken by the body is having more power. Okay, so this is what power actually, students. Okay, so here we are having average power, that is the total work done in total time. Okay, as I have told you the power thing, power is equals to work done upon time. This could be the formula if we shorten up it in a symbolized manner. So average power is again total work done, total time taken. That is the average power. Okay, if simple power, work upon time, total work, total time is average. Like average is somehow like if you are doing work in taking a gap, like this one is done, this kind of work is done, and then there is a time gap in between. this work is done, then again there is a long time gap, then this work is done. So if we want to find total power, so in terms of these three, so here we are not going to take these times here, we just going to take the time that is taken when the work was done, when the work has been doing, like here the work is done till this point to this point, so we can take the time for this part only, time for this part only, time for this part only. So the average means total work, total time divided by total time, that is average power. Okay, so SI unit of power is watt. Okay students, so this is not joule as I have told you. E and P is similarly shown to be like alike, but actually they are not. The time factor is working here, and that is being introduced by the scientist. So on behalf of him, we have put the unit of power as watt, and this is how we going to recognize it. So whenever you will see something like 5 watt, so this is what, this is actually the power that is being given. And what is power? It is energy by time, or we can say work upon time. How much work has been done in a particular time, that is shown by the watt. So students, we have seen what is power, and the SI unit for it is watt. So this is not just the watt that is the only SI unit of it. It has different units. Okay, so what are these? Here is the table that is showing that watt is the symbol for it is W, and 1 watt is equals to 1 joule per second. Okay, how come joule per second? You know that here power is equals to what? Work done upon time, and the SI unit for work done is joule, and the SI unit for time is second. So joule per second together can be written as watt. Okay, so here that is why I have written like this. Fine, but watt is again very small unit. So for that, continuing it to the greater part, we are having a kilowatt. Kilowatt is equals to what? 1000 watt in 1 kilowatt. Now this kilowatt even is a small quantity if we are taking this thing according to the electricity part. Like in electricity also, you know that the electrons are actually moving from through the wires, that is why it generates electricity. So electrons have to do work. So their work is converted into the energy, that is electrical energy, and here the work done by them is calculated with respect to time, and that is known as power. So in terms of electricity also, you have seen in behind of different gadgets also, like behind of bulb it is written like it is working on 10 watt, 12 watt, 100 watt bulb. Okay, so what is it? It is the work done by that bulb in a particular time. Okay, so megawatt is again the higher quantity, that greater than the kilowatt, that is the 10 lakh watt in 1 megawatt. Okay, and again some sort of small unit that is used in the electricity department only, you just keep learn this thing, that is 746 watt. If the number 746 together is written, and this watt denotes 1 horsepower. So these are the different units of power. I hope you understand power very well. And the term power is, you will see that there is different various ways that we were using it earlier, but now according to the physics, your concept has been cleared. Now you are going to use in a correct manner, and you might have seen that at your home appliances. Check the back side of it, you will see how much horsepower, how much watt is written there.